in my previous video, that is the working principles of Wheatstone bridge. So this one will deal with working principles of metal bridge, and inshallah I will show you the relationship between the two. So this one work on the principle that the ratio of resistance here must be equal to the ratio of resistance here when this galvanometer is pointing to 0. That is the point of no deflection. So we call it Mr. and Wheatstone bridge because it has two spaces that we need to bridge or cover with resistor or any conductor. Therefore, according to my own, I will use R1 to block this space. This is one terminal and that's another one. Then I will use this resistor R3 to block this space. This terminal will be connected to galvanometer. Then this is jockey that you use to touch the wire that will determine what at the point where the galvanometer is pointing to 0, you stop your jockey there. Now, according to what we have here, let's assume that from here to here is x1, while the rest of distance from here to here is about x2. Then the resistance of the constant wire from here to here is R2. Resistance here is R4. Therefore, according to what I said, if this is the point where the galvanometer is pointing to 0, we are going to have R1 over this distance, that is x1, which is equal to R3 over this distance, which is x2. And don't forget, the whole distance from here to here is 100. If from here to here is ordinary x, so therefore we are going to have R1 over x is equal to R2, R3 over the rest of distance, which will be this x minus, 100 minus this x, and 100 minus x. So therefore, let's compare it with what we got in Wheatstone bridge. So if the distance from here to here is R2, let's replace this one with R2. We're going to have R1 over R2 is equal to, then the rest of distance will be replaced with what? The R4. We have R3 over R4. And you can see that we later arrive at the same formula with what we got in the case of Wheatstone bridge. Then let me tell you, since the resistance of constant wire, resistance of constant wire filled with the length, so we can apply the method of resistivity that says resistivity mu is equal to Ra over L. For this side, that must be equal to the other one. This one is equal to R, if this one is 1, 1, 1. R2, A2 over L2. Over L2. Now, this one for this side must be equal to this. So therefore, we are going to have R1, A1 over L1 is equal to R2, A2 over 100 minus L1, since the whole length is 100. Then resistance, cross-sectional area of the wire is constant. So this one cancel this. So at the end of the day, we arrive at R1 over L1 is equal to R2 over 100 minus L1, which is same thing as R1 over X, according to the first one, is equal to R2 over 100 minus X. So that's why. So inshallah, the next video will be on practical use of this one in the laboratory.